In the previous video, we walked through the foundation of smart charging load management, the part of the system that protects your electrical infrastructure by making sure the site always stays within its safe capacity. Today, we're moving to the second core element of smart charging, charging strategy. If load management determines how much total power is available, charging strategy determines how that power is allocated across vehicles. And if you are a fleet manager, depot operator, EV infrastructure specialist, or sustainability manager, you don't just need vehicles charged, you need the right vehicles charged in the right order to meet real-world service commitments. With tools like BetterFleet, charging becomes an operational advantage, one that supports dispatch schedules, readiness targets, and service reliability. Now, let's get into it. Once we understand that the goal isn't just to charge vehicles, but to charge the right ones at the right time, the next step is recognizing that not all vehicles have the same charging needs. Some return to the depot early and sit for long hours, while others arrive late and need to be out again first thing in the morning. Batteries also accept power at different rates depending on their state of charge. A smart charging strategy accounts for these differences and uses the available power in a way that supports operational readiness, rather than simply splitting it evenly or following a fixed pattern. It is important to understand that there are two different charging hardware setups which impact charging strategies. In a parallel charging setup, multiple vehicles may receive power simultaneously, which is ideal when there are many vehicles and limited charging windows. In a sequential setup, one vehicle charges at full power at a time, and when it finishes, the system moves to the next. This works well when dwell time is long and grid capacity or charger capability is limited. So it is critical that you consider charging hardware options in concert with determining the right charging strategy for your site, because choosing the right hardware strategy pairing can increase throughput efficiency and help you charge more vehicles in the same amount of time. Now, let's cover your strategies. In a simple needs-based approach, power is shared evenly among all charging vehicles. This works best in predictable environments where dwell windows are long and departure times are consistent. In other depots, a first-in, first-out approach reflects physical layout and positional priority. Vehicles closest or in the first charging row receive power first so they can be moved out of the way, making space for subsequent vehicles. This system is often used where yard flow and physical access are the main sequencing constraints. Some of the strongest efficiency gains come with priority-based charging. Instead of treating every vehicle as equal, the system allocates power based on operational need. For example, vehicles with earlier departure times may charge first. Vehicles with lower state of charge may take priority over vehicles that already have substantial energy. Vehicles assigned to critical services or longer routes may be charged ahead of others. In emergency or utility fleets, priority can even be assigned dynamically based on real-time dispatch needs. The value here is practical and measurable. It minimizes last-minute reshuffling of vehicles, reduces reliance on emergency charging, and ensures the majority of priority vehicles reach their target SOC in time for departure. It also maintains higher fleet utilization and keeps service performance stable, even as operations become more complex. This becomes even more powerful when charging is schedule-driven. Instead of just following a queue or reacting to plug-in order, the system uses operational schedules or duty cycle data to understand exactly when each vehicle needs to leave and how much energy it must have at departure. This allows the system to work backwards from required departure time readiness, making charging a proactive planning mechanism rather than a passive activity. Every EV battery charges in two distinct phases. During the bulk phase, when the battery is near empty, it can absorb power quickly and efficiently. During the soak phase, when the battery is nearing full, power acceptance slows dramatically. A smart charging system recognizes this and shifts power away from vehicles in the slow soak stage and toward those in the fast bulk stage. This dramatically increases total throughput, improves utilization of charges, and results in more vehicles being ready sooner, all without increasing grid draw. Just as in part one, it's important to remember that EV charging does not exist in isolation. It shares power with lighting, HVAC systems, maintenance equipment, bus washers, and other site loads. Charging strategies need to account for these. If operations shut down for the night and general site load drops, charging may accelerate. If machinery ramps up or HVAC load spikes, charging may momentarily slow to keep the site within electrical limits. This ensures readiness without risking infrastructure. Ultimately, the charging strategy is about aligning energy supply with operational demand. It ensures that vehicles are not simply charged, but charged optimally to support service delivery, fleet productivity, and customer experience. It turns charging into an operational tool rather than a passive utility. Betterfleet enables this orchestration by allowing operators to choose the strategy that fits their specific depot, blend strategies where needed, and evolve the logic as the fleet scales and operational realities change. Using a fleet-focused CMS, charging can be fine-tuned to service schedules, SOC requirements, duty cycles, and real-world constraints so that every vehicle is ready when needed without unnecessary infrastructure upgrades. So if part one of smart charging is about ensuring electrical safety and capacity, and part two is about using that power intelligently for readiness and efficiency, then the logical next step is cost optimization, ensuring you are charging at the lowest cost periods, avoiding demand charges, and reducing total energy spend. We'll explore that in part three. In the meantime, if you'd like to see how these approaches could be applied in your own depot, we'd be glad to help. Reach out to the Betterfleet team and we'll walk through your operational patterns, charging requirements, and constraints, and help you build a smart charging strategy that delivers confidence, predictability, and performance.